Last month, both Zilog and the Z80 were in the tech news, well, the and finally section of the tech news, as they were finally going to cease production of the Z80 processor, or at least the original 5-volt version, a microprocessor that has been in production the entire of my life. Oh god, I feel old. And why lots of column inches went on the various machines that have been powered by the Z80 that have been part of our lives growing up. Surprisingly little space was dedicated to the actual Z80 and its design process and the company behind it. Maybe all those newspapers thought, yeah, that's a bit too nerdy to cover that, but if there's one thing I've been pleasantly surprised by from all you viewers out there, that apparently we're all quite into the nerdy stuff. So we're going to have a look at the history of the Z80 and Zilog, the company behind it, and also we'll have a look at a new retro machine that's making use of the Z80 processor, Andy Toon's Microbeast. And if the word Microbeast sounds a little bit familiar, and you're thinking that sounds suspiciously similar to the phrase microprofessor, there is a reason. But before we get stuck into all of that, let's have a brief word from our sponsor, PCBWay, fine purveyor of printed circuit boards. Yep, you design it, you send it to them over the interwebs, and the PCB comes back in the post, in exchange for money, of course. You can even have some components put on that PCB for you as well via their pick and play service. Again, in exchange for, money. After all, PCBWay does have to make some money so it can afford to sponsor half of YouTube. It's also about to have its 10th birthday, so in a few short years it'll be off to high school. Between them, the Z80 and the 6502 were basically the two main 8-bit processors that everything used from the mid-70s through to the end of the 8-bit era. And even after that, the Z80 was cropping up in all sorts of weird and interesting places. From the first handheld consoles, to things like My Burger Alarm. And despite the fact that this processor basically has a 50-year history behind it, the people who created the Z80 are pretty far from being household names. I mean, the main names people know from the computer industry is one person who's basically a professional Kermit the Frog impersonator, and a jumper-wearing narcissist. Neither of whom can really be said to have, invented anything. I mean, one more so than the other, but even then. Yet, who, for example, knows who Federico Faggin is? Well, we're about to find out. Now, as you can probably guess from the fact that I used his name in a video about Zilog and the Z80, that he's pretty important to the story of, Zilog and the Z80, as he is one of the founders of Zilog and also one of the designers of the Z80. But he should be pretty famous for stuff that doesn't even include Zilog and the Z80, or at least as famous as Bill Shockley, because he is the person who invented the self-aligned metal oxide semiconductor, the thing we used to make all microchips with pretty much, all RAM, CCDs, CPUs, pretty much everything. He may not have been the person who invented the transistor, but he's the person who invented the way of laying out the transistor that, we actually use. So Federico Faggin was born in Italy, and at age 19 went to join Olivetti's R&D labs, where he was part of the team that developed one of Olivetti's early computers. After that, he went to study physics for 3 years at university, where he then joined Fairchild in Italy, and then moved to the United States, where he developed the self-aligned silicon gate transistor, which is what every chip you've ever used is based on. Now, whilst working at Fairchild and having come up with the thing that, was the future of all microchips, Federico felt like he didn't quite get the recognition he deserved, and that's because he didn't get the recognition he deserved. I mean, they gave Shockley a Nobel Prize for inventing a transistor that didn't work very well. So Federico Faggin did what most people who worked for Fairchild seemed to do, which was leave. And he went to join the company set up by two former Fairchild employees, Gordon Moore and Robert Noyce, known as Intel. And on joining Intel, he found himself being chucked in at the deep end, being put in charge of the project for the 4004, a chip intended to essentially be a calculator on a single chip, and is what many regard as the first microprocessor. I mean, it's sort of not. There's that processor that was used in the F-14, the Central Air Data Computer, which may have got there first. I mean, it is a bit of an odd beast, but I think it's almost there as the first microprocessor. But a lot of people didn't know about it at the time because, it's in a military aircraft. You kind of tend to keep those things a little bit secret. And also, architecturally, it's a little bit odd to say the least. But it'd be fair to say that most people regard the 4004 as the first microprocessor, even though it may not have been. But at the time, Federico Faggin certainly thought it was. The problem for him, though, is he was dropped into the project partway into it when it was already going very wrong. Like a lot of the things that Intel produced at that point in time, the 4004 was not intended as an Intel product as such. It was being done under a contract for another company based in Japan called Busicom that made, unsurprisingly, calculators. And they were the company that contracted Intel to produce this chip so they could produce a single chip-based calculator. And in Federico's first week, Busicom had sent Matsutoshi Shima, sorry for the pronunciation, I probably just butchered there, Mr. Shima, all the way over from Japan to see how much progress the 4004 had made. And the answer was not a lot. And according to Federico Faggin, what he essentially told Matsutoshi Shima was that he could either just put up with where they were or to stop bitching and help out. Now, amazingly, he decided to stop bitching and help out. Now, you may think that's me paraphrasing this, but apparently not. That's a literal quote from Federico. Now, for someone who'd never done any work like this before, it turns out the man was absolutely brilliant at it. I mean, we will come back to Shima again later on because people throw around the label genius quite a lot, but in this guy's case, yeah, he probably actually was. Now, initially, the 4004 was exclusively going to be for Busicom, but somewhere along the line, NICE became persuaded it'd be a good idea to renegotiate their contract with Busicom and make a non-exclusive version of the chip that could be sold to others. Following on from the 4004, Faggin was put in charge of developing Intel's next chip, which had eventually become known as the 8008. Following on from that, we had the 8080. And that was the Intel processor that helped kickstart the whole microcomputer revolution, with machines like the Altair and the MSI being based around it. But Faggin had become quite disillusioned with Intel as an organisation. He was trying to push for the microprocessor to become the thing that Intel really got stuck into, that would become their main product. But it seemed like Intel's management were just not that interested. Everyone kept agreeing with him that it was important and it was the future, but no one seemed to want to do anything about it. So Federico decided he needed to start his own company to work on microprocessors. And apparently one night in a bar with Ralph Ungerman, who also worked for Intel, they decided that they would create a new company. And apparently after a few more nights in bars, they eventually decided on the name of Zilog. During Federico's leaving do that apparently happened on Halloween, Matsutoshi Shima asked if he could leave with them. Unfortunately, they pointed out they didn't actually have enough money to hire anyone at all, but as soon as they did, they would give him a call. Now, the idea was to create a CPU that would be a superset of the instruction set for Intel's 8080, as they knew there was a ready-made customer base for that chip. All they needed to do was design one that was better, and ideally easier for computer vendors to make their board around. And with the Z80, they achieved exactly what they set out to do. The Z80 can run any code that's been assembled for the 8080. But it also has extra instructions over that chip. It also has more registers, 14 versus 7. It also has built-in circuitry for doing DRAM refresh, so you don't need an external chip to do that, or SRAM. The chip also needs a single 5-volt power supply instead of 5-volt minus 5 volts and plus 12 volts that the 8080 used. This makes it a lot simpler for anyone who wants to design a system around the Z80, as they don't need to carry around a whole different bunch of power rails or provide something to handle DRAM outside of the processor. So this makes it a lot easier for someone to implement something around the Z80. And this is something we first start seeing in the real world once the Z80s come out. For example, a lot of the early micros, like the Altair and the MSI, first start using Intel's 8080. But as we see more and more S-Bus style computers start to appear, well, the processor boards start swapping over to using a Z80 instead. And in fact, through the 70s into the very early 80s, the Z80 becomes the CPU for business-focused microcomputers, particularly those that run CP/M. Now, this is where we should probably talk about CP/M for a little bit. When the first 8080 micros were started to come into use with their S100 buses, they didn't really have an operating system. I mean, they didn't even have so much as a boot ROM. And this is where Gary Kittles decided he'd step in and create an operating system for those machines, CP/M. And that combination of a S100 bus machine with an 8080 and CP/M kind of became the standard business micro for that period. And as time went on and computers stepped away from using the S100 bus but stuck with the 8080 or Z80, that combination still continued to dominate the business micro market, right up until IBM released its PC. Although CP/M did get released for other microprocessors like the 6502, the 8086 and even Motorola 68K, and of course the follow-on to the Z80, the Z8000, the 8080 version of CP/M was still kind of the primary version. For example, two of the major 6502 based platforms, the BBC Micro and the Apple II both received hardware add-ons that provided them with a Z80 processor so they could run the Z80 version of CP/M. In fact, Acorn's BBC had two, one from Acorn themselves and one from Torch. And Apple got one from a little startup called Microsoft. I wonder whatever happened to them. Now, although CP/M itself only targeted the instructions for the 8080, rather than the superset of instructions for the Z80, each individual computer manufacturer had to produce their own BIOS for CP/M. That's the bit that's responsible for doing the machine-dependent stuff. And for those who were implementing a machine using a Z80, well, they'd use Z80 assembler for their BIOS. Application vendors also had a choice to make. If they wanted it to run on the widest range of systems, they'd target only the 8080 instruction set and registers, so their application would run on CP/M on all the 8080 and Z80 based machines. However, if you did target just the Z80 instruction set, well, you could get a bit more performance out of your code. So we would see some applications be written mostly in 8080 assembler, with just some bits of code path to test whether it was running on an 8080 or a Z80, and if it was running on a Z80, well, it'd target the Z80 instruction set and optimize small bits of code here and there that are doing the maths heavy parts. You'd also get little utilities, either them being public domain or shareware, where the developer would just target the Z80 because either that's what they had, or that's what they preferred, or they just wanted that little bit more speed. But that meant that there was software out there that would work on just the Z80 and not the 8080 for CP/M. So this became one of a number of factors driving manufacturers' machines intended to run CP/M towards using the Z80 over the 8080. Coupled with the fact that the Z80 was cheaper than the 8080, and it was also cheaper to implement a computer around the Z80 came to absolutely dominate the world of CP/M. After all, if you were in the market for a CP/M machine, would you buy the more expensive one, or the cheaper one that's a bit more capable? Would you buy the one that could run more software, or less software? Effectively, Zilog had gone with the strategy Embrace and Extend, a technique that would be used to devastating effect against CP/M in just, a few years' time. Early success in the S100 market also led to Z80 being considered in other areas. For example, as video game arcades started to become a thing, we started to see the Z80 getting used in some of these cabs, like Pac-Man for example. When we start seeing microcomputers becoming a thing for the home and school markets, well, the Z80 gets to be hugely successful there. For example, of the three big machines released in 1976, the TRS-80 based on the Z80. In my home market in the UK, well, we'd see an explosion of Z80 machines, as Sinclair based pretty much all their machines that were commercially successful around them. For example, the ZX80, 81, Spectrum, all Z80 based. Amstrad, for example, released two separate lines of computers that were both quite successful based on the Z80. We had the CPC, which is kind of its own OS but could possibly also run CP/M, and then they had the PCW, which was their CP/M based line of machines. Japan also had a booming market for the Z80. All 2000 models of the Sharp MZ series, all based on the Z80. The MSX platform, versions 1, 2, 2+, all based on the Z80. Australia's Microbeast, Z80 based. There were also trainer computers based on the Z80 as well. For example, the Microprofessor from Multitech, although you probably know them under their more modern name of Acer. In short, although the Z80 started off with the idea of competing with the 8080 on the sort of product ranges that the 8080 already sort of fulfilled, new markets soon opened up and expanded, and the Z80 was one of the two processors that made that happen, along with the 6502. When we talk about the 8-bit era, mostly what we're talking about is the Z80 and the 6502. I'm going to take a brief segue into the world of microtrainers for a minute or two. Now, these were fairly simple computers built with the idea of teaching you how a machine works, rather than one being built to run pre-written software. Now, probably one of the best known examples of this is the Microprofessor 1 and 2, and you'll not be surprised to discover that it's based around the Z80. After all, in the video about the Z80 and Zilog, it would be a bit weird to start talking about one based around the 6502. Now, the main thing about these trainer computers is that they're fairly simple. That's the idea. They're fully self-contained. There's nothing too complicated in there. You can understand the whole machine pretty much, because that's the whole idea right there in a nutshell. It's a machine that you can use to learn about how computers work. And while you could do things on them, as they came, there typically wasn't a lot there. You had a keypad for doing input, and I mean keypad, not really full keyboard. There was usually some form of display, not that dissimilar to that of a calculator, and if you were really lucky, you'd have a port so you could save and load things from cassette tape. Now, This lack of features kept the machines very, very simple, which meant that they were easy to understand and learn to program with. They would also help keep the cost down, because typically these trainer kits needed to be relatively cheap, so the schools and educational institutions that these things were targeting could actually afford to, buy enough of them. Now, it's not really a class of device we have anymore, but at the time, this is how many people got to experience a computer for the first ever time and learn to do real things with them. I mean, these kits would typically have a monitor on where you could enter instructions for your Z80 CPU into memory and then set the instruction pointer back to a location and execute the code that you managed to put in. Some even had languages like BASIC. But the primary aim was to create a machine simply enough that someone could understand the whole machine and drive the hardware from the CPU and learn that skill set that you would need to understand more complicated computers. This is something you'd really struggle to do with any modern machine, as typically the chip that controls the mainboard that boots up your primary processor, that has more sophistication than the whole microprocessor range. So this is where we see Andy Toon and his Microbeast stepping in. What Andy's created is a modern machine, in the sense that it's not reliant on sourcing obsolete components, that you can build it's of the scale that you can fully understand it and how everything in it operates. Now, that doesn't mean that you have to do everything from the ground up yourself, though he has done things like write a firmware to start it for you, for example, although you get the source code to that. In fact, you get the source code pretty well explained for that. He's also managed to port CPM to it and has written the BIOS for it, so you can actually run CPM software. You can run the machine completely standalone from any modern devices. It has its own little display and keyboard, which your CPM BIOS is perfectly capable of driving, so you could play Zork on this thing. One whole line of Zork at once, but you can play Zork on this thing. Which, when he was showing this stuff off last November at Retrofest, amused the hell out of me. If, however, you're feeling a bit less like a masochist, you can plug your modern computer into the USB port it's got, and the built-in USB to serial port will connect you to the Microbeast, and you can then fire up a terminal emulator and have your Microbeast talking to a VT100 or VT220 or whatever it is you chose to emulate, which gives you a somewhat more sophisticated display and means that you can run software that was pre-written for CPM that was targeting one of those terminals. So, you can run Zork with, more than one line at once. How exciting. But the main thing this gives you is a computer you can completely understand and learn every little bit of that machine. And Andy's provided every last little bit of documentation you need in order to be able to do that. So, for example, I now know how to drive the serial ports on this thing. Admittedly, I've been doing that with the emulator he provides. Oh yeah, he provides an emulator, so you don't have to go through the pain of typing all the assembler directly in on the Microbeast keyboard itself. You can use your own computer and then test the stuff out, and then once you've got it working, run it on your actual Microbeast. Now, I should probably briefly say, why the Z80? After all, this is a video about Zilog and the Z80 and not the Microbeast, although it may be feeling a bit Microbeast heavy right at this point. Well, the Z80 was one of the two standard microprocessors of around the time that Andy is harking back to. It's also simple enough that you can understand how the Z80 works and does everything that it does, whilst not being so unsophisticated as to be completely useless. Most of us have never written code that directly targets a processor. We've not done the whole assembly thing, unless you're old and crusty like me. If we've done any programming at all, we've done it in higher level languages, or even higher level languages than the things that we used to call higher level languages. So in order to give us a device that we can do that with, well, he needs something that is simple enough to get your head around, but not so simple as to be, well, useless. And the Z80 ticks that box extremely well. There's also a ton of documentation and tools for building things for the Z80, and a huge wealth of software that's portable across multiple machines that had a Z80, thanks to CPM. Also, given his history as a games developer, I dare say Andy's done more than his fair share of coding for the Z80. Although the last time we were in the pub together, it was not a Z80 game we were talking about. Yeah, one day you should ask him about the surprising role that Halford's car mats played in the development of certain game titles. Now, as I've alluded to, or stated there, Andy's a games developer, or certainly was back then, so you might be thinking, for a guy who created a machine, it's surprising that it doesn't have graphics, given that he was, a games developer. Well, it turns out Andy's got us covered and has created a graphics card for the Microbeast, well, and for other machines as well if you can find the memory hole in which to, get it in the address space, and it's called, wait for it, the Video Beast. And this thing gives us, well, surprisingly good graphics, to an arcade sort of level, with multiple scrolling background sprites, you name it. He's implemented it using an FPGA rather than a little microcontroller, and it has a megabyte of graphics memory in there, which you address for a little windowed system. Obviously 1 megabyte does not fit into the address range of a Z80 overly well. So when you add this to a Microbeast, the thing suddenly has really good graphics capabilities. I mean, beyond any machine from the 1980s. But you don't have to put the Video Beast in a Microbeast, you could actually put it in any 8-bit retro computer of the time, more or less. It connects up like say a 4K memory chip would, in that you have some data pins and some addressing pins, and it all runs at 5 volts. As long as you can find some space in the memory map to put that thing in, you can use it in pretty much any machine. I'm kind of tempted to see if I can get it running in a BBC Micro. I should also mention that he is working on a mini version of the Microbeast, a small handheld variety that looks like those Casio handhelds from the 1980s, the ones that had an actual real processor in them. As a pocket version of the Microbeast would be inordinately cute, but also gives a version that people can have where they don't have time to build a kit, because he's planning on surface mounting all this and just providing a finished machine rather than here's the PCB and all the parts. This means that people who are really time poor like me can join in the fun of actually having the hardware as well, because the biggest barrier for me using a hardware Microbeast is finding the time to build said Microbeast. Honestly, if I don't have an excuse of saying making a video about something, I really don't have the time to, build it. Now in hindsight, I could have used the last section as an excuse to build the thing, but apparently I didn't think of that. So I'm just gonna have to wait until the pocket version is ready to be sold. I really am an idiot sometimes. We should probably go back to having a bit of a look at Zilog. Initially, when Zilog first starts up, it's one of those small companies where everyone involved basically is designing the processor or is in some way involved in that. They don't really have the kind of budget that allows them to have ancillary people working there. So Federico Faggin, for example, whilst also being the MD of Zilog, he's in there designing the Z80. Same with Matsutisha Shima, who's busy doing all the logic layout. Ralph Ungerman, from what I can tell, is not only dealing with finance, helping with circuit design, he's also writing all the test software to run on the Z80 as well. So this is an incredibly small team for doing what they're doing, particularly by modern standards. And there are some really impressive feats going on here. Matsutisha Shima, for example, he's gotten so good with logic layout, while they're having meetings discussing features, he's actually designing the logic layout on a piece of paper, and in the meeting can say whether it is worth the size it will take up on the die or not. Another example is Ralph Ungerman found a logical problem with the chip. And apparently, Matsutisha just sits there, goes quiet for a minute or two, and then says, we need to just change these 2 gates. In order to come up with that answer, he must have run the entire logic of that thing in his head. That's not the sort of thing that most human beings can manage. But not only was the team clever, it was also savvy as well. Now, a good example of that would be the traps put into the design in the Z80. Now, it was fairly common around that time that Japanese chip manufacturers would essentially steal other companies' designs. Essentially, they'd just take a successful chip, open it up so they could see the die, and just copy it. But what Federico Faggin figured out was that they could put in stuff that looked like a normal gate, but wasn't. So if someone were to copy the design through just visual inspection, well, they'd assume there are gates where there weren't really gates. And in some cases, those gates would just break the entire processor. Or in other cases, just have a subtle effect that would render the whole chip either very unreliable or useless. Apparently many years later, an NEC engineer would tell one of the team that the traps had succeeded in stopping them from making a Z80 clone for about 6 months. Now, that time was vital, because it meant that with their silicon partners, Zilog could get their things into mass production so they hit the cost point they were aiming for, and establish supply relationships with customers, all before some cheap Japanese clone managed to undercut them. Initially, the founders of Zilog thought that the Z80 was going to do well in the embedded market, that it would essentially act as a logic replacement for a ton of custom logic that people would put into devices. They knew the calculator market existed, and they had seen the beginning of the microcomputer revolution whilst they were at Intel. But even they couldn't see how successful the whole microcomputer thing was going to become, and how vital the Z80 was going to be in the early years of that. I mean, basically every computer created around this period either uses the Z80 or the 6502. And not only had Zilog created a great processor in the form of the Z80, it also created a whole bunch of ancillary chips around it as well. They had also become very popular in Z80-based systems, but also their I/O chip, for example, had become so popular it was being used in systems that weren't even based on the Z80. However, despite all its initial success, Zilog never really managed to repeat the success that it had with the Z80. For example, in 1979 it released a new processor, the Z8000, which is a 16-bit CPU. And while it shared a number of design features with the Z80, it was in no way instruction compatible with the Z80 CPU. This meant that there was no existing codebase for the Z8000. Now, other CPU manufacturers would continue with designs that were backwards compatible with the chips they produced before, so the whole software base didn't have to be binned effectively. And while the Z8000 did see some use in some computers, like the Olivetti M20 for example, it never did build up a big base. And this whole not being backwards compatible thing means that when Motorola launched their 68000 processor, a couple of months after Zilog released theirs, when the 68K turned out to be roughly twice as fast, for system designers, the 68K was a more obvious choice. After all, neither of the two chips had a software catalogue that already exists for them, so you'd may as well choose the one that's, well, faster. Now you may be thinking, why on earth did Zilog not make a chip that was instruction compatible with the Z80 in that case? Well, they did. The Z800. That was a 16-bit variant of the Z80 with its own MMU. It was backwards compatible with all the legal instructions for the Z80 and could address a whole 16 megabytes of RAM. Which may not sound like a lot of memory now, but in the 1980s that was an absolute shed load of memory. But the main issue for the Z800 was simply that Zilog seemed to ignore the fact that they made the thing. They were so intent on pushing the Z8000, their 32-bit chip, that they basically just ignored this thing. It did also have some issues running software written for older Z80-based platforms, because you'll notice earlier I said it was compatible with all the legal instructions, all the, documented ones that Zilog were prepared to admit was in the CPU. However, there were a number of undocumented instructions as well, opcodes that would turn on bits of the chips and do something useful, but not something Zilog intended you to use. The problem is, that did not stop software developers exploring these opcodes and then using them in their software, so compatibility was not as good as you might have hoped. One company that did pay some attention to the Z800 was the ASCII Corporation, one of the two main companies behind the MSX platform, and they created their own variant of it called the R800, which they used in the Turbo R version of the MSX platform. This was after Microsoft had kind of dropped out, so it was just the ASCII Corporation. So sadly, this is right towards the end of the lifetime of the MSX platform, where not a lot of people cared or bought it, so we never really got to see what the R800 could do. Now, this is where we're going to swing back to that bit of Exxon foreshadowing we did earlier. Because Zilog having Exxon as essentially their investor, well, it did cause some problems. The first and most obvious one is that it caused Ralph Ungerman to leave, as apparently he'd have regular disagreements with Exxon. But Exxon had also been investing in a lot of companies in the computer and chip industry, as Exxon had always had a big interest in computing, and had also had a pretty unhappy relationship with IBM. And Exxon essentially wanted to build up its own division that could rival and eventually take out IBM. Hence Exxon had been investing in all sorts of companies with that aim in mind. And their interest in Zilog had been more about Exxon's ambitions than really wanting to back the plucky little CPU vendor. Zilog's involvement with Exxon, and Exxon's ambitions with regards to IBM, meant that the Z80 missed out on possibly the biggest opportunity of the 1980s. IBM wanted to get into the microcomputer business, and it needed to get into that business quick. After all, IBM had already missed out on a whole market segment that was the mini-computer, by basically ignoring that sector for too long and being too late to market with their offering. And it really didn't want to make that mistake a second time, and the microcomputer market was fast developing. So IBM created a separate business division with the instruction of use off-the-shelf parts, get a microcomputer put together as quick as you can. And of course, the obvious choice of microprocessor for that machine was the Z80. After all, for business users, running CP/M as their operating system, the Z80 was the CPU of choice at that point in time. But IBM, having got wind of what Exxon had planned, told Project Chess that was creating the IBM PC, you can't use the Z80. After all, they did not want to put money in the pockets of what they saw as a potentially big rival. So that meant IBM had to look at someone else, and it went to Intel. And that's basically because IBM didn't have a choice. If they wanted to be able to run the version of CP/M they intended to run on their machine, then, apart from Zilog and the Z80, Intel's 8080 was basically the only game left in town for them. And although the IBM PC wouldn't end up shipping with CP/M, I mean, that's a whole other video, the choice of Intel CPU made it fairly easy to port software over from CP/M to DOS. If Zilog had not been funded by Exxon, well then IBM would have been free to choose the Z80 and probably would have done. So there's a good chance that in the 1990s all our PCs would have had a little sticker on them reading Zilog inside instead. That fateful purchasing decision from IBM and the explosive success of the IBM PC, combined with the fact that the Z8000 never had the kind of commercial success that Zilog hoped for, meant that by the early 80s, Exxon were able to take 100% ownership of Zilog, which some might think was Exxon's plan all along. It's also fair to say that Zilog had a bit of bad luck with the 8000. I mean, for example, they had some significant delays in getting their memory management unit chip that was meant to accompany it, the Z8010, into scale production. Now, given they were aiming this chip at the same place that the 68K was aiming for, which is basically Unix workstation kind of territory, having a big delay on your MMU, which is something a Unix system very much needs, was a bit of a problem, and meant that it did delay a number of machines that were going to be based around this chip. And the biggest loss from this catalogue of potential machines that we could have seen but never did, or at least as far as I'm concerned, is the Commodore 900. Now, this was not just a pipe dream machine. Commodore actually got this thing built and working, and it ran a very Unix-like operating system called Coherent. But because it was delayed, and Commodore had managed to get its hands on Amiga, they decided to drop the 900, which meant that we could have seen a home computer in 1985 running a version of Unix. But we never did. Now, at the time, Commodore was one of the most successful computer manufacturers in the world, and they really did have the kind of muscle that could have turned this thing into a success. But then Commodore had a complete change of management, ended up owning Amiga, and in Europe they did make a good success of the Amiga as a platform. In fact, it's one of the platforms I owned as a kid and I really liked it. But it's never what you call a hit with business, or at least not in the US and not specialised businesses doing video editing, for example. But from that point of view, a Unix workstation for Commodore could have been a whole different kettle of fish, particularly a very affordable Unix-based workstation. But Zilog itself kept on ticking, at least in one form or another, as Exxon never did become that IBM rival that they had planned in their heads, and so over the years Zilog has changed hands from many owners from one to another, sometimes losing the brand altogether, ready to bring it back again. But during that whole period, Z80 stayed into production. For nearly 50 years, there has always been a Z80 being made somewhere by someone, including that original 5-volt dip-packaged part. Even if you're not a retro computer collector with tons of Spectrums and Z80-based machines littering your entire house, your house will still contain some Z80 CPUs, be them in charge of your light bulb, a thermostat, your oven, your doorbell, or in my case a burglar alarm. The Z80's success as an embedded chip to be shoved in practically every design going, or as just a licensed IP block to stick in an entirely different chip design, the Z80 has been incredibly successful. And its life isn't over yet. While they may finally have stopped manufacturing that 5-volt original Z80 part, various successors that are Z80 based but have a slightly different instruction set, well, they're not stopping manufacturing those. They're also not stopping license it being thrown in as a chunk of design in other chips either. For example, fairly common IDE chipsets that make your SATA drives go, that are taking your IDE instructions and turning them into sort of sector, cylinder and head requests, well, a lot of those are based on the Z80. So if you're familiar with Z80 assembler and fancy dismantling a disk firmware, well, you'll see a lot of Z80 instructions in there. And that's because when you bump up the clock frequency, the Z80 is pretty capable of doing that stuff, but also, there is still a tool set around for doing stuff with Z80. And if you're a designer putting together a chip and you want something to just be a generalized processor in there so you can avoid having a ton of logic, well, the Z80 is very well understood and has a ton of tools for it, so why not just very cheaply license a Z80? The Z80's big rival from that period as well, the 6502, well, it's still getting used in exactly the same way as well. Yep, old designs never disappear, they just become a smaller and smaller chunk of a bigger design. If you've got all the way to the end of this video, I'd like to say thank you very much for watching. I hope you've enjoyed this little stroll through Zilog's history, and hopefully you'll remember some of the names of the people responsible, so they might, one day, be as well known as the odd narcissistic jumper wearer. I would also like to say a big thanks to Andy Toon for taking all the footage of the Microbeast for me, because I didn't have a completed Microbeast I could take footage of. If you enjoyed the video, there is a button to indicate that fact that's shaped like a thumb. And if you didn't, well, there is another button too. If you really liked the video and would like to help the channel out, then please feel free to click that subscribe button, because apparently that's what gets YouTube to tell people that these videos actually exist.